Namaste and welcome back to JEE Mathematics with Typical Monk. This is class 16, the hyperbola. The ellipse held a constant sum. The hyperbola holds a constant difference. 2 points on the plane, and every point of the curve keeps the same gap between its distances to them. And the curve breaks into two open branches that raise outward, forever hugging a pair of straight lines they never quite touch. Today, we read the standard form, place the foci, and draw those asymptotes, one idea at a time. Here is what you will learn today. First, the standard equation, the foci, and the eccentricity, which is greater than 1. Second, the asymptotes and the relation between A, B, and C. Third, the difference of focal distances property, which equals 2A. Fourth, the Latus rectum and the conjugate and rectangular hyperbola. And fifth, ellipse versus hyperbola and the drills. One idea at a time. 4 ideas. Run this entire chapter. Look at them together first. The standard form, x squared over a squared minus I squared over b squared equals 1, 2 branches, opening left and right. The foci and eccentricity. The foci sit at plus or minus AE, 0, the eccentricity E is greater than 1, and b squared equals a squared times, bracket, E squared minus 1. The asymptotes. The lines y equals plus or minus b over a times x, the branches hug them at infinity. And the difference of focal distances. For any point on the curve, the size of s-p minus sp equals 2a. That is the defining property. Now look at the picture, the anatomy of the hyperbola. The definition first. The hyperbola is the locus of all points whose distances to two fixed foci have a constant difference, 2a. The branches and vertices. There are two open branches. The vertices sit at plus or minus a 0, and the transverse axis of length 2a lies between them. The foci and the relation. They sit at plus or minus c, 0, where c equals a e and b squared equals c squared minus a squared, which is a squared times, bracket, e squared minus 1, so c squared equals a squared plus b squared. The asymptotes. The lines I equals plus or minus b over a times x far out, the branches approach them, but never touch. Now, the working formulas, the ones the exam turns into marks. The ribbon holds the anchors, the standard form, the eccentricity, and the asymptotes. The eccentricity. E equals c over a, always greater than 1, and b squared equals a square times, bracket, e squared minus 1. Note the plus against the ellipse's minus. The Latus rectum. The focal chord perpendicular to the transverse axis has length 2b squared over a. The rectangular hyperbola. When a equals b, the asymptotes are perpendicular, and the eccentricity is the square root of 2. Its rotated form is xy equals c squared. And the conjugate hyperbola. Y squared over b squared minus x squared over squared equals 1. It shares the very same asymptotes, but opens up and down instead. Let us read a whole hyperbola end to end. Take x squared over 16 minus y squared over 9 equals 1. We will find a, b, the eccentricity, the foci, the asymptotes, and the Latus rectum. Read a and b. A squared is 16, so a is 4, b squared is 9, so b is 3. Find c and e. C squared equals a squared plus b squared, which is 16 plus 9, equal to 25, so c is 5, and the eccentricity e equals c over a, 5 over 4, which is 1.25, greater than 1, exactly as it must be. The foci and vertices. The foci are at plus or minus 5, 0, the vertices at plus or minus 4, 0. The asymptotes. Y equals plus or minus b over a times x, that is plus or minus 3/4 x. The Latus rectum. 2b squared over a 2 times 9 over 4, which is 4.5. One reading of a and b gave the whole hyperbola. Now the picture that separates the two conics, the ellipse against the hyperbola. They are 1 sign apart. The ellipse carries a plus between its two terms, the hyperbola carries a minus. The ellipse. It is closed. B squared equals a square times bracket 1 minus e squared with e less than 1, and the sum of the focal distances is 2a. The hyperbola, it is open with two branches. B squared equals a squared times bracket e squared minus 1 with e greater than 1, and the difference of the focal distances is 2a. And the trap. Watch the sign inside B squared and the range of the eccentricity. That single flip is all that separates the two conics. Now what JEE actually asks. 5 pointers. 1. X squared over a squared minus I squared over B squared equals 1 gives foci at plus or minus a comma 0. Eccentricity E equals C over A greater than 1. B squared equals a squared times bracket E squared minus 1 and C squared equals a squared plus B squared. 2. The difference of the focal distances, the size of S dash P minus SP equals 2a. The definition of the hyperbola. 3. The asymptotes y equals plus or minus b over a times x and the latest rectum 2b squared over a. 4. The rectangular hyperbola I equals b perpendicular asymptotes, eccentricity the square root of 2 and the form xy equals c squared. And 5. The conjugate hyperbola y squared over b squared minus x squared over a squared equals 1 shares the asymptotes opening up and down. Now a true or false drill. For each claim, decide if it is true, and if it is false, find exactly where it breaks. Claim 1. For a hyperbola, the eccentricity E is less than 1. That is false. For a hyperbola, E is greater than 1, and eccentricity less than 1 is an ellipse. Claim 2. The asymptotes of x squared over squared minus I squared over B squared equals 1 are the lines I equals plus or minus B over A times X. That is true. Those are exactly the asymptotes. Claim 3. For a hyperbola, B squared equals a squared times bracket 1 minus E squared. That is false. It is B squared equals a squared times bracket E squared minus 1. The 1 minus E squared form belongs to the ellipse. Now match each feature to its formula. The eccentricity goes to C over A greater than 1. The B squared relation goes to a squared times bracket E squared minus 1. The asymptotes go to y equals plus or minus B over A times X. And the difference of the focal distances goes to 2a, 4 pairs, and each one is worth committing to memory. Now, how many of these 3 statements are correct? 1. A hyperbola has an eccentricity greater than 1. That is correct. 2. The 2 branches of a hyperbola cross their asymptotes far away. That is wrong. The branches approach their asymptotes but never cross them. 3. For a rectangular hyperbola, the eccentricity is the square root of 2. That is correct. So the answer 2 are correct statements 1 and 3. The trap is statement 2. The branches approach the asymptotes without ever touching. Now the 2 mistakes that quietly cost marks. The myth for a hyperbola, b squared equals a squared times bracket 1 minus e squared, like the ellipse. The truth, b squared equals a squared times bracket e squared minus 1 with e squared minus 1. The 1 minus e squared form is the ellipse. The second myth, c squared equals a squared minus b squared for a hyperbola. The truth, c squared equals a squared plus b squared with a plus. It is the ellipse that has c squared equals a squared minus b squared. Now, test yourself. Answer in your head before the reveal. That is how JEE speed is built. Here we go. Question 1. The eccentricity range of a hyperbola greater than 1. Question 2. The asymptotes of x squared over 9 minus y squared over 16 equals 1. Here b over a is 4 over 3. So y equals plus or minus 4/3 x. Question 3. The value of c for x squared over 16 minus y squared over 9 equals 1. C squared is 16 plus 9 25, so c is 5. Question 4. The eccentricity of a rectangular hyperbola. The square root of 2. And question 5. The difference of the focal distances 2a. Let us gather it all in one breath. The standard form x squared over a squared minus I squared over b squared equals 1. Foci at plus or minus I e comma 0. Eccentricity e equals c over a greater than 1. B squared equals a squared times bracket e squared minus 1 and c squared equals a squared plus b squared. The plus separates it from the ellipse. The difference of the focal distances. The size of s dash p minus s p equals 2a. The asymptotes y equals plus or minus b over a times x the latus rectum 2b squared over a. The rectangular hyperbola I equals b, eccentricity the square root of 2, and the conjugate shares the asymptotes. Next class, limits, continuity and differentiability, where the algebra of curves turns into calculus. A hyperbola is one constant difference, two open branches racing outward along a pair of asymptotes they never quite reach, and it differs from the ellipse by a single sign. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack JEE. I will see you in the next class.